All right, next up we have an update on iSER from Eyal Salomon from Mellanox.
So I will go over iSER update of the issues that Mellanox handled this year concerning iSER. The agenda will go on iSER advantages and status, support for new targets that we did this year, LIO, SCST, TGT enhancement, initiator features and update on Linux and VMware, and performance acceleration. As Bart said, block multi-queue. We are working on SCSI multi-queue. We're expecting those patches to be publicly released, and we will do work on that. And I'll talk about iSER block device. It's another block device that we try to simulate the blocking multi-queue and the SCSI multi-queue to provide better performance result and see where are the bottlenecks in those layers. In the end, I will talk about the OpenStack and the iSER integration with that through Cinder. So the advantages. Mellanox put in a lot of investment on the iSER because it has few of advantages that our customers are looking for. One of them is that the iSER is enterprise storage solution. It provides security, it provides HA and discovery, and more features that are more on the enterprise storage requirement. So for that, iSER is a better solution for us. It has tool and integration based on SCSI. You use the same. You have a set of tools that enables you to implement and provide SCSI with a very easy set of tools, easy to use and easy to deploy. Another advantage is that it supports Ethernet and InfiniBand. We don't have to write everything twice. And the third part is that on the last measurement that we did, we found that on some situation it's even faster than SRP, both on IOPS and latency. It's probably concerned with what Bart said before of the contention that we have in the kernel, and that there are no multi-queues. Probably now when there are going to be multi-queues, we will have to measure again and see the result again. So about the status of the iSER. iSER is already for a few years part of the kernel. It's constantly improved. We are putting a lot of patches to accommodate requirement from the customers and to make the performance better and better. It has a seamless integration today into OpenStack. We are developing tools to integrate it into OpenStack. And the last issue is that it's adopted by many cloud providers. Cloud provider require iSER subsystem, and we will see those solutions in the few coming months. So this is a table that summarizes a few of the target support that we did. So SCST subsystem support the SRP. It also supports the iSER. It has no support for fiber channel over Ethernet. The TGT, which is a user space, it doesn't have support for SRP, but it has support for iSER. So it doesn't have support for fiber channel over Ethernet. LIO, which is another target, it has a kernel implementation. It has support for SRP. It has support for iSER. And there is a work to do a fiber channel over Ethernet. It's in progress, and it will be released. We within the few months. As for licensing, some customer requires licenses which are GPL-free. They want closed solutions for the code. So there are several issues with that. So SRP is an open source, is a GPL. And if a client wants to have a GPL-free code, it has to be based on the license of the SCST. On iSER, there is a possibility to get from Mellanox GPL-free license, and LIO has no GPL-free. It can be based on the LIO license. So let's talk about LIO. LIO iSER is supported from kernel 3.10. We did a lot of work on that. We work on the feature of T10diff, which is actually its signature offloading. It's allowed to do a CRC or data integrity operations on the data itself. It's been done by the hardware itself. It's implemented in T10diff framework in the target core. Implemented for iSER. There is fully offloading transport. You can do add or strip or pass to verify the T10diff info. The data, the CRC or the signatures can be overlaid into the data, or can be created by a separated metadata file. And this is also these all features are exported by the target. We also did work with performance. We did a performance optimization to bring LIO do a better performance and to compete with other subsystems. SCST. For SCST, this year we wrote a completely iSER TGT driver. There was no such. I will show performance results in the next slides. So we extended the SCST to support RDMA as well as TCP. We see that on SCST we get IOPS and bandwidth. It supports now InfiniBand, the Rocky, and the IRAP, and it's available on this link. So here is an example of SCST target, a transport comparison. This is a single initiator and single target using a HP machine with Intel 2650 CPU. They have connected 3X adapter tested on 40 gig Ethernet or FDR. So in terms of bandwidth, we can see that on 4K kilobyte messages, SRP is getting 4,000 megabyte per second, and the iSER SDR is also achieving those numbers. As for let's talk about I/O latency. So I/O, what we benchmarked is 4K I/O. We see that SRP is around 4,000 microseconds. On the I/O on the latency graph, less is better. We measured on iSER FDR less than 100,000. Less than 1,000 microseconds. As for IOPS, we can see that on IOPS we get on 1K message size around 900 900 kilo IOPS per second. And as Bart said before, those are limitation of a block device. Usually you get around 1 million IOPS per second. So what we did on the TGT, on the iSER. So on TGT, what we worked this year to provide sophisticated polling strategies to maximize the IOPS. We did optimization on the polling issues around the polling CQ. We try to balance between CQ or network operation and on the IO operation, and we got a very good result with that. We added support for iSCSI discovery. We changed the allocation of memory pools in the target to use huge pages. That's minimize the HCA cache misses. We did support for multiple instances of TGT. That's for IOPS scalability. And now we also support larger IOQ depths. There is a support for the memory buffer that the TGT allocates. It's used to allocate a rigid size of 1 gigabyte. Now it can be configurable with parameters that you run the TGT. You can also configurable the CQ affinity, which provide a better scale out of the iSER itself. On the initiator side, we did some work on the Linux side to work with VM over SRIOV virtual function. We added support for fast registration through the driver. We had support for iSCSI discovery. We did some optimization to change the fast path locking scheme in the lib iSCSI that provides a better performance. We did support for a larger IO queue depth. And the last one is that we support or working on support for T10 signature offloading or protection. We did some stability fixes, and this concludes the work on the Linux side. We are working on the VMware solution. It's integrated now into ESX 5.1 or 5.5 as an iSCSI hardware offload. We work on a native port to ESX6 kernel, and nowadays it's in development. So, as we can see, I will now talk about the iSER block device. The iSER block device that we wrote is trying to emulate the SCSI multi-queue and the block device multi-queue. We emulated those function as we suspected that there is bottlenecks on those layers that eliminate us from reaching the maximum result that the network can get. So in terms of I/O latency, we can see that the iSER block device can get up to 600,000 IOPS. We are talking about IOPS of 4K IO size. You can see that we're reaching that almost the same with read or write, or a sequential or a random read and write. As for CPU, we can see that we get very low CPU in that loading. We get up to 2% of the CPU percentage of work. This is all accessing a single LUN. When going and accessing a following in parallel, you can see that the system is scaling out. Everything is jumping on the magnitude of 4 almost. until you reach the PCI limits. You can see that on IOPS you get excellent result of 2.3 million IOPS, and that's a very good accomplishment. It's and that is 5 or 10% the latency under 20x of the workload. So about the multi-queue. As I said before, the iSER initiator exposed a SCSI block device to the operating system. Both the block and the SCSI layer are performance bottleneck for IOPS scalability. In Linux 3.13, the block multi-queue was introduced to the block layer for generic block devices. And the SCSI multi-queue is under work, as we heard before, by the community, and the iSER is planned to leverage on that. So the results that I showed before are obtained with a prototype that we did. Again, it's called ISBD, which emulate the block and the SCSI multi-queues. So those are the results. When those features will be matured, those are the results that we are expecting. Last thing is about iSER in the OpenStack community. There is huge demand for iSER in the OpenStack community. With using building components and management that are already released, so-called the Open iSCSI and the TGT itself and the Cinder plug. The RDMA is already inbox and can be used in our OpenStack customers. Mellanox enables faster performance with much lower CPU utilization. And the next step is to bypass the hypervisor layer and add NAS and object storage to the OpenStack. Thank you. Yeah. Any question? Yes.
Is there any work being done to eliminate reliance on having to have a TCP/IP stack running to get the iSER initiated, connection initiated? So can I run it in a pure IB or RDMA environment? Especially for folks that are in the embedded space that don't want to load an IP stack.
We plan to do that in the next year. We didn't do it until now. It's on our plans. Yes,
you mentioned the word pool when you were talking about the target memory receipt. Do you cache memory registrations in that pool? What's the memory registration strategy?
Yes, what there is in the target, you allocate one large buffer of, it was 1 gigabyte of memory, and it was partitioned to small buffers. It will all registered as once, and that it was recycled all the time by the target. Now, what I said is that it's now configurable. You don't have to. What we did is used pages to allocate these buffers, and now this buffer is configurable, and you can decide how much memory you want to allocate for that buffer. Any other questions? Okay, thank you.